Okay, this is the homework guide to exercise set 2.4. This can be the key. Okay. So the first one, you're looking at functions and you're just labeling where these statements are true. So the first one is intervals where f of x is increasing. So I gave the first one for you from -3 to 1. Notice it's going up here, right? So it's increasing. Where else is it increasing? Well, it's also increasing here from 7 to 9 or 7 to infinity, whatever you want to say. I'll take either of those. Let's do 7 to 9. Okay. Um, Intervals where we're decreasing. So again, I gave you one from 1 to 7, right? We're decreasing from here to here. We're also decreasing from -5 to 3. -5. Oh, whoops. -5 to 3. Okay. Where is it concave up? So remember, concave up happens when our slope is increasing. So I gave it for you. It is concave up from -5 to -1. Why is that? Because look at the tangent line. We're very negative. We're less negative. We're less negative. We're 0. We're more positive. We're more positive. We're more positive up until this point. So this is all concave up. Then it switches. This is concave down because we start getting more shallow to 0 and then start getting negative. But right here is kind of the most negative it gets, right around here. And then here, we're actually going to start coming back up, right? We're getting less negative to 0, right? So if you think about this is very negative, this is less negative, this is less negative. We're at 0. This is positive. This is more positive. This is more positive. So you can look at the tangent lines to find where it's concave up. So it looks like we're concave up, I would say, from I don't know, we'll call this, I mean, it looks like 4.5. 4.5 to 9 is where we're concave up. This is a mistake. I apologize. This is concave. This -5 to -1. It is not concave down from -5 to -1. I'm sorry about that. That is a mistake. It is concave down from -1, right? What I was saying before, we're going less. So this is like positive, and then we're at 0. So it's getting, and then we're at negative, and then we're at more negative, and then we're at more negative, right? So right here, this is all concave down. So from -1 to, I'll write it down below, -1 to 4.5.
Hello, and so sorry for the interruption.
Okay. And anywhere else it's concave down, that is it. There's actually only one interval where it's concave down because this is concave up and this is concave down, getting decreasing, and then it goes back to concave up. So it's just this whole thing can go. It's just this one interval, -1 to 4.5. So relative min or max, this is a min. This is a max. This is a min. Okay. And then points of inflection. So points of inflection are where we change concavity. For my intervals, I can see the only point I'm changing concavity here was 2 points I changed concavity. Right here at -1, this is a point of inflection, and right here at 4.5, these are points of inflection. Okay, so that would be at -1 and 4.5. Okay, let's do another one. Let's keep it going. So these are challenging. These are definitely challenging. They take time. Yeah, just take your time. Is my best advice. Okay, next one. We got another function. We're looking for where the derivative is greater than zero. This just means the function is increasing. They're the same thing. So this right here is the same as this right here. When I say the derivative is greater than zero, that's the same as me saying the function is increasing. Where is it increasing? Well, it's increasing from, I'm going to say negative infinity because I don't know what this kind of goes on forever, right? I don't really know where that goes to 1. So it stops right here. And it's also increasing from 4 to, this is kind of a tricky one. This is from 4 to 8. You might be tempted to say like 8, 4 to infinity. The problem with that though is if you look at 8, we have a flat portion here. That is not greater than 0. That is 0. It is 0 right here at 8. Right? So you have to do another interval from 8 to infinity. Okay, so you should have 3 intervals for that one. Where is it less than 0? So this just means decreasing. This is the same as this. They're saying the same thing. Where is it decreasing? Where's the slope negative? Well, so again, it was going up here, it was going up here, it was 0 here, and it goes up again. Okay. Where's it decreasing? Only decreasing here from 1 to 4. One interval of decreasing. From 1 to 4. Okay. Where is the second derivative greater than 0? So that is the same thing as concave up. Second derivative greater than 0 is the same thing as concave up. Where is the slope increasing? So again, this is where you kind of want to sketch out the tension. This is very, very positive. This is this is less positive. This is even less positive. This is 0. This is negative. This is more negative. This is less negative. This is 0. This is positive. This is more positive. This is regular positive. And we're at 0 again. And then we're at positive. And then we're at more positive. So when I get those pluses and minuses are just like indicating how steep it is. So we're really steep up, medium steep up, less steep up, 0, light negative, medium negative, light negative, 0, light positive, medium positive, light positive, 0, light positive, heavy, medium positive. They're just marking the slope. So where is the second derivative going to be 0? Where is it going to be concave up? Well, concave up means increasing slope. This is decreasing. We start increasing right here. So I go from this medium negative to light negative. So this is increasing, 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 increasing to here. So from 2 to 6, I'm concave up, or my second derivative is positive. Also, we shallow out here, but then we get steep again. So from here, this is another point. We get to 0, but then we get steep again. Also from what looks like 7.5 to infinity, we are concave up. Because look, we go 0, positive, double positive. So where the second derivative negative is wherever this is not positive. So negative means concave down, meaning decreasing. So we're decreasing here. Steep, medium steep, less steep, 0, negative, medium negative. So from negative infinity to 2. To 2. We are concave down. Then we go concave up again. And then we have a little bit of concave down here because I go from this medium steep to 0. So from 6 to 7.5. And that's it. So, I mean, I'll kind of mark it here so it's visually you can see. This is concave down. Cave down. This is concave up. This is concave down. And this is concave up again. Okay? Um, Min or max, those are pretty easy. This is a max, relative max. This is a relative min. That's it for min and max. And then these solid dots here, these are all inflection points. So this, and this, these are all inflection points. Okay. All right. So as you like, these are tough problems. Like they take a while to do. You just have to take your time. Vocabulary is super important. That's why we did the flashcards. Like knowing, okay, when you see this, that means it's increasing, right? So this is the next ones are similar but different because we're looking at the derivatives. This is what we did in the group activity today, towards the end of class. So you were looking at the derivative and using the derivative to tell you when it's increasing and decreasing. So remember, when the derivative is positive, the original function is increasing. So from this is a ton of typo. That should be -7 to -2. From -7 to -2, f of x is increasing. And then again, from -2, right? So this is f of x increases. From -2 to 5 as well, because the derivative is positive. When is f of x decreasing? Whenever it's negative. So that would be right here and right here. This would be f of x decreases. This is f of x decreases. Okay. So that would be, so again, 5 to infinity, I gave it to you, and then -infinity to -7. Okay. When is it concave up? So it's concave up whenever whenever the first derivative is increasing. So from here to here, we're increasing, we're going up. From here to here, we're increasing, we're going up. So it's these two intervals. So from -infinity to, what does that look like? To me, that looks like -5.5. And then -2, I gave it 2 to 3. When is it concave down? So whenever it's decreasing. So we're decreasing here and here. There's not, I apologize, there's not 3 intervals for this one, it's just 2. It's from -5.5 to -2, and then from 3 to infinity. Okay. Label where the relative min or max would be labeled any points of inflection. So min and max happen when we change from signs. So we're going from negative here to positive here. So this right here will be we're going down to up. This would be a relative min. And this one is going from positive to negative. So this would be a relative max. And then the points of inflection are where we change from increasing to decreasing. This right here will be a point of inflection. And this right here will be a point of inflection. Okay. Next one. So this is, in a way, this is easier. This is saying the same thing. Where is it decreasing? This is the same thing. Where is it positive? Positive from -8 to -1. And positive from, let's say, 3 to infinity. So again, this is where the original function is increasing at these intervals. Okay, remember we're looking at the derivative. This is the derivative. The original function will be increasing on these intervals. Where is it less than zero? Well, it's less than zero here and less than zero here. This is f prime of x less than zero. This is f prime, the derivative of x less than zero. Okay, so it's going to be negative infinity to negative 8 and negative 1 to 3. Where is it? The second derivative positive or concave up? Again, that's where the first derivative is increasing. So that's from negative infinity to, I don't know what this looks like. What's the peak of this? Again, negative 5.5, same as the other one. And then from, where's the bottom here? I don't know, we call it 1.5. Somewhere right here. Yeah, we'll call it 1.5. So it's increasing here. So that's where it's concave up. Where the first derivative is increasing, that's concave up. So we'll say negative infinity to negative 5.5 and 1.5 to infinity. That will be concave up. Where is it concave down? The second derivative is negative, would be here only. Only. So that would be from the region between these two, negative 5.5 to 1.5. Where the min and max is going to be. So again, we're going from negative here to positive here. So this one will be a relative min. And again, we're going from, so here we're going positive to negative. This will be a relative max. And then this one, we're going negative to positive. So that would be a relative min. Okay. And points of inflection will be here and here. These are points of inflection where we're changing from increasing to decreasing. Okay. All right. This is drawing the derivative. Draw the derivatives of the function shown below, and the inflection points are marked by gray dots. Sketch the tangent lines to help you. So, yeah, I'd say this is a good time to sketch some tangent lines. So, always a good place to start is where the derivative is zero. So, remember, the derivative is zero at those relative mins and maxes. So, you want to start by just plotting those first. Okay, so that's I'm kind of doing on both right now, but that means that my derivative should be hitting zero at negative 7. It should be hitting zero at 1 or negative 1 rather, and it should be hitting zero at 7. Okay, so what's it doing in between these points? Well, to the left of negative 7, it's positive, right? To the right, it's also positive. Oh, sorry. Negative. My bad. Just pause, ignore that. It's going up. I'm looking at the tangent line, right? My m is positive. My m is 0. My m is negative. My m is more negative. My m is like normal negative, light negative. Then it's back to 0. So let's graph this. We're going to go from positive to 0 to negative to more negative to less negative, back up to 0. Okay. So again, always touching 0 at these peaks and troughs, peaks and valleys. Should always be heading back up to 0. Then after this, we're back to being positive, more positive, less positive, and 0. And then we're going to do a little bit of negative. So here we're going positive, less positive, back down to 0 here, and then we're going to have a little bit of negative. So the only thing I want to note is see these gray dots here where this inflection is, this should be where the derivative is turning around. So right here at 2, I try to make that clear. But we are going from increasing back to decreasing. That's what that's saying. We're going from concave up to concave down. All right, so this is it. This is inflection. Then also there was one right here at -2, 3, -4. Oh, that one turned out fine. So this is also an inflection because we're going from that decreasing to increasing. All right, next one. Try it by yourself. Start with that. Start with the strategy. So find where it's 0, 0 here, 0 here, 0 here, and mark them. So we're gonna have -7 right here at 0 and at 7 again. And then you say, okay, what's happening between these? So we're negative here, then we're positive here, we're more positive. This is where I should be turning around. Less positive, 0, negative, more negative, less negative, back down to 0, and then positive. Okay, so let's see. I'm going to start negative. I'm going to come up to 0. Right, this is 0. Then I'm going to be positive. I'm going to be more positive, and I want to be turning around at this inflection point at -3. So I can go up, kind of peak at -3, and I'm going to come back down. That's my inflection point. This point here should match this inflection. Okay, back down to 0. Then I'm light negative, more negative, turning around at 3. So I'm going to turn around at 3. Okay, again, another inflection here. And then so light negative, back to 0, and then light positive. That's my derivative. So I think if breaking it down into steps, it's like identify the zeros, identify the horizontal tangent lines, plot them, and then figure out what the slope is between those points. So if it's negative, then if the slope's negative to the left of it, it's negative here. If it's positive here, right? So whatever the slope is doing should be reflected by positivity and negativity of the derivative. All right. Sketch a function f for which the following statements are true about its slope function f prime, or the derivative of f. Okay. So we're sketching the original. So let's mark some of these. So x less than -3, we have 1, 2, 3. 3 to -1, it's doing something. So I'm going to mark that. And then above, okay, fine. So for less than -3, my derivative is positive, meaning increasing, and slope is increasing, meaning concave up. Okay. From -3 to -1, I'm still increasing, but it's concave down now. At -1, I equal 0. So that means like it's a critical point. It's going to be, I can tell from looking at this is going to be a relative max. And then after that, I'm going to be, my derivative is negative, so I'm decreasing. And the derivative and concave down. Okay. All right, let's sketch it. So from before -3, so this is -3 right here, this is -1. Before -3, I'm increasing and concave up. So look at my slopes going up here, getting steeper, getting steeper, getting steeper, getting steeper, getting steeper. And then here I'm still increasing, but now I'm going to start getting shallow, 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 until right here, my derivative right here is 0. See this flat? So look, plus, 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 steep, 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 getting steeper, shallowing out here, right? So less steep, more steep, more steep, less steep, 0, and then now I'm decreasing and concave down. So I'm coming down and getting steeper down. So it should look something like this. Okay. All right.